Good morning, everyone. Water pollution is getting worse as factory discharge sewage, which contains heavy metal ions, which causes harm to the aquatic life. Sugarcane bagasse, being waste usually, can be used for removing heavy metal ions in water by changing it into nitro-oxidized nanocellulose. In this project, we investigate 5 different types of heavy metal ions to find the absorption capacity and the average weight or absorption for nanocellulose.
The sugarcane bagasse can be converted into NONCS via 3 stages. First, it can be delignified by heating with sodium hydroxide solution. Then, the delignified bagasse can be bleached by reacting with sodium hydroxide and hydrogen peroxide solution. Finally, the bleached cellulose is reacted with sodium nitrate and corn nitric acid to form NONCS. This formula is used to find the absorption capacity, and this one is used for finding the average rate of absorption. To find whether the metal ions have been absorbed by the NONCS, they are tested with the testing reagents, which will give observable change to show the presence of the metal ions.
The small pieces of dry sugarcane gas is heated with sodium hydroxide solution with stirring for 1 hour. The delignified gas was bleached by warming with hydrogen peroxide and sodium hydroxide solution with stirring for 1 hour. The bleached cellulose was filtered off and cleaned by adding distilled water. The treated cellulose was warmed to dry. The treated cellulose was then reacted with corn nitric acid and sodium nitrite solution with stirring for 2 days. It was diluted by adding distilled water, standing overnight, filtered off and cleaned by adding distilled water. The NONCS was dried at room temperature. For finding the absorption capacity, the maximum concentration of the heavy metal ion solution with no observable change with the testing reagent was determined. A known mass of NONCS was put into the heavy metal ion solution with known concentration and volume. The time of no observable change with the testing reagent was recorded. The steps were repeated twice. Similar procedures can be done for finding the average rate of absorption.
The percentage yield of pretreated cellulose production is 33.6%. And the percentage yield of nanocellulose produced from pretreated cellulose is 49.9%. So the overall percentage yield is 16.77%. For finding the absorption capacity, the maximum concentration of metal ion solution for having no observable change with testing reagent were found. The mass of nanocellulose, the volume and concentration of metal ion solution, and the shortest reaction time for having no observable change with testing reagent were found. The absorption capacity is the highest for copper 2 ion and lowest for mercury 2 ions. For finding the average rate of absorption, similar data were also recorded. The average rate of absorption follows the same order as in the absorption capacity.
For producing nitro-oxidized nanocellulose, the nitride ion first reacts with hydrogen ions to form nitrosonium ions, which oxidize the hydroxyl groups in cellulose into germinal hydroxyl groups. The nitrosonium ions further oxidize the germinal hydroxyl groups in cellulose into carboxyl groups, which are responsible for the chemical absorption of heavy metal ion. Hydroxide precipitation is always used for removing heavy metal ions in wastewater. However, the concentration of some metal ions are still too high for some aquatic lives, even after the precipitation. Nanocellulose can further lower the concentration of heavy metal ions after the precipitation.
The overall percentage yield of nanocellulose production is 60.77%. The nanocellulose had different absorption capacity and average weight or absorption for heavy metal ions. The nanocellulose can absorb heavy metal ions in low concentration quickly, although the absorption capacity is low in the beginning. Thank you.